broadcast preparing. I'm going to check this in a minute too.
Sorry.
Just want to check. Okay, so was there any, okay, it's working. Was there any, were there any questions on yesterday's homework?
I still don't get how to use the same cost as
Okay,
tab.
so I did talk to you a little bit yesterday about that, right, Cliff? And if
Yeah.
you're still having troubles, I'll come over and try it.
Like, I'm able to.
So let me do it again, okay? I'm gonna do it quickly again, and then we will go on to, the solving angles, which will just reinforce what you're learning anyway. Okay. So let me try it again. If you want, you can try, if you find you have no questions, you can try, working ahead to the angle stuff, and I'll catch up to you shortly. Okay, so as I said yesterday, Pythagorean theorem is a great way to solve for a missing side of a triangle, but it only works, Pythagoras only works if I know two lengths of the sides of the triangle, right? So when you have this side given to you and this side, you can find this side, agreed? Or if I know this side and this side, right, I can find a third side. That's Pythagoras. What we learned yesterday, though, is if you only know one side of a triangle, right, 54 meters perhaps, if it's a right angle triangle, and I don't know another side, but I do know a degree measure, I got another set of formulas I can use, not Pythagoras, but you can use my right angle trig formulas, and they're called the primary trig ratios. They're called the trig ratios, and there's three of them: sine, cos, and tan. They all, the math is very similar, but the reason we have three, sine, cos, and tan, is it depends what side you're given according to the angle, right? You'll always be given one angle in the question, and you'll be given a side either opposite or beside it or the hypotenuse. So these three trig ratios, the sine, cos, and tan, only work for right angle triangles. And you'll notice that, now these are generic triangles, meaning there's no side lengths given or no angles, but as long as there's an angle given, an angle used as a reference point, and here thetas are a symbol for an angle, right? It's just an unknown angle measure, but it's representing the measure of how wide this arc is, right? That's what an angle's measure. I guess I should make my arc a little nicer. Okay, so if this is the angle that they're telling me to use as the reference point, then according to this angle, this would be the side opposite. Agreed?
Yeah.
The longest side of a triangle, the hypotenuse, that never changes. That's consistent from Pythagoras and from these guys, right? So you could maybe label that guy first. If this is the opposite side, this has to be the adjacent. That's the third label that we have for these guys, okay? Now you'll notice something, or I hope you notice this, is that the angle itself, the angle, if I look at this angle here, okay? There are two, every angle, and maybe that's what everyone should understand first. If I have two line segments or two lines like this that are connected, this little space they created, this is called the angle, okay? All right? So angles are measured in degrees. Now every angle is created, needs two rays to make it, right? To create it. The two, in a right angle triangle, one of the rays is always going to be the hypotenuse, and the other ray will be the adjacent, okay? The side of the triangle that isn't part of the angle measure is the opposite side, all right? So if you know that, if you find your angle, you know that the two rays that make the sides that make the angle, that create the angle, one of them has to be the hypotenuse, the other's the adjacent, okay? The leftover side's the opposite. All right? So for this one, this of course is the hypotenuse, this has to be the adjacent, this is the opposite. Make sense,
Yeah.
Blanca? Tanis, how about you? Are we okay? This one, Cliff, this obviously is the hypotenuse,
Yeah.
right? Then the other, wherever the angle is, that has to be adjacent, that has to be the opposite.
Yeah.
To me, that's the most crucial lesson in this whole triangle unit for the right angle stuff. If you can label your triangle properly, you can do the questions, because then it's just a matter of substituting into a formula, which I know you guys know how to do. That's just polynomial substitution. So, once again, this lesson is all about solving for a missing side, right, in a triangle. That isn't a Pythagoras question. So I look here closely, and I have an angle indicated for me. So here's my angle measure, okay? What I'm going to do is I label the sides of my triangle. I'm going to use slightly different words today. You'll notice I've got 3 sides of a triangle, right? Obviously, because a triangle is made as a 3-sided shape. One of the sides, the opposite side, in fact, is completely, it's not really part of the question. Agreed?
Yeah.
I don't know if you can see that. It's just blank. There's no X. There's no, right? So the sides that all I'm going to do is label the sides with the number and with the X. So this is the hypotenuse, and this is the adjacent side. Okay? Now, if you wanted to, you could label the opposite, but what I would tell you is I would get you to erase that anyway. I just want you to label the 2 sides that are part of the question, that you'll need for the question. Okay, now that's crucial. If you can't really get what I'm talking about, stop me now. But this side, it's completely blank underneath, right? There's no X, there's no number, don't label it. All right, once you do that, that is going to tell you which formula you need. You're going to need one of the 3 formulas. To solve for a side in a right angle triangle, if you've got an angle given to you, you're either going to use cos or sine or tan. Only one of them will fit the question. Only one of these guys will work for the question you're working on. That's why you need 3 of them. They fill all your purposes. So I see adjacent and hypotenuse. Which one am I going to have to use? Cos, right? So I record my formula. I actually write my formula out, okay? And I've got 3 places in the formula where numbers will go. This is one place where my number will go. I'm just going to grab another color. I've got the theta. The theta will be replaced with a number, the A and the H. Hang on a sec, guys. Do you have one? Okay. So do you see I have, this is a number, right? It's a number, it's a degree. This is a number as well. Now this isn't a number, but it's a variable. So these 3 pieces of information get substituted into my formula. All right? So cos theta represents an unknown angle, right? Well, now we know what the angle is, because in the formula everything's unknown. Now I'm substituting my values in. This is what we did in polynomial substitution at the very end, right? A, well, what does A represent? A is my variable in this case, and H is my 29. Okay? Now, what we said yesterday, I sort of used cross multiplication to explain it, but in a shortcut way. When X is on the top of the ratio, it just becomes a multiply. I just cross multiply these 2 guys. 29 times cos 72. And whatever the answer is, that's the answer. Now, I had got you to kind of get used to clearing your calculator out when you came in. So you turn it on, and then I go the blue button, second, and the plus sign, second mem, and you'll press number 7, and it's just asking you to clear all your memory. And we do want all the memory cleared. Let's clear it all. They're just double checking. Yeah.
Second.
So the blue button and the plus sign, right above the plus sign it says memory. And that's what you're trying to clear the memory. We're pressing the blue button because anything in blue has to be accessed first by the second. Yeah, number 7. And I want all RAM cleared. They're just double checking here. Do you really want to clear your RAM? I do, so I'm going to move down to number 2. And I'm going to reset. And then it should say RAM cleared. Now that's just to clear it from the previous class because they had a whole bunch of stuff entered. All right, now does anyone remember what else I told you to do? After you clear your memory, it goes back to defaults.
You put it in degrees.
Yeah, so the next thing you got to do is make sure your calculator's in degrees. So once again, I press the mode button right beside second, right mode, and the second option down says radians or degrees. We want degrees. So you can just move your cursor arrows too.
I put second and mode in that.
No, just mode, because you just want mode.
Oh,
Yeah.
and then, sorry.
You can use your cursors and you can move down to where it says radian, and then just move your cursor over to degree, okay? Once it's blinking on degree, just press enter, which is right down at the bottom. Enter is going to be your equal sign, and it's also your enter sign, right? Okay, now I want to get out of this. I know I'm in degrees. What do I do, everyone?
Clear?
I don't think, oh, clear does work. Sorry, it does. You can also go second quit, clear. Okay,
You can also put on and off too. There's
that's
no-
true. That's the default, right? You can
Yeah.
always just turn it on and off. Okay,
But
we
the
good?
second degree
I still don't
Yes,
understand how you
it
got
only
lost.
will clear out if you
Reset it?
reset it, which most students are trained to do because they're using it for programming and all that stuff, yeah.
How did you know that cost was like, the 72 degrees was going?
Because theta, I defined it for you 2 days ago, theta represents a degree measure. This is the only number with a degree.
Oh, okay, so
Remember I
everybody
told you
has
that?
Okay.
Yeah, theta represents an angle. There's only one number that's an angle here, right? It's the 72 with the degree symbol. Okay, so now, sorry,
It represents an angle.
29 times cos 72 equals 8.96 millimeters. Okay? Are we good? No? Okay. Janice, are you okay?
Theta represents an angle.
And you can close the bracket.
Could figure it out.
Okay, I don't think you changed, so let's go to mode again. Yeah, you're still in radians. Okay, so move your cursors down, or this part was. You want it highlighted though, so move it down. Okay, and now move it over and go enter. There, now you've got degrees on. Clear? Now try it again. 29 times cos 72. There you go.
You'll get completely different answers in radian. By the way, radian is still a really effective way to measure angles, but that's a pre-cal approach and we use degrees, okay?
What is radian measure again? Temperature is degrees. I can't remember what is a radian? No, a measure
Radian,
of-
I'll explain it later
Okay.
to you,
If
but
it's measured
radian
in
measures angles, but it actually measures it more accurately than degrees.
Yeah, it's-
And I'll show you why. Yeah, I can come show you because it's interesting. Okay, where's the angle? Find the angle because the angle's the boss. Here's the angle, right, Cliff?
Yeah,
Okay.
okay.
Tell me what sides I need to label.
Well, the X is the hypotenuse,
Yep.
and, the 27 feet is the opposite.
Okay, and that's all I need. I just
Yeah.
need 2 sides. So which trig ratio does that lead me to?
See, that's where I get lost every single.
Don't say that. Cliff, which trig ratio does that lead you to? Look here.
O and H,
So which one does that lead you to?
the sin.
Yeah. Okay.
Okay.
So here's my formula. I always write my formula out. Sin equals O over H. Okay. Now we're doing the same thing. We're just substituting values in, right? All right. Which number goes where the theta is? It's the degree, right?
3,
Which number is that?
55.
The 55. And
And the opposite is 27. 27 on the top.
Yep. And the x is on the bottom. Okay. Now the reason these two examples are given to you is if you're solving for a side, you're solving for one of these numbers, right? You're not solving for the angle. You always know the angle for these questions.
Okay.
So the x will either be on the top or it'll be on the bottom. When it's on the top, it's a straight multiply.
Plus,
Yeah, when it's on the bottom, I can see if I cross multiply, it's not going to give me my answer. We have to do a different technique, and I did show the steps yesterday. But basically, it boils down to, if x is on the bottom, instead of the number times the trig ratio, it's the number divided by the trig ratio. And I think I showed this once in the early days of this class. If I'm looking for the bottom number for the x, it's just a switch. You just switch the two numbers, right? Because they both multiply out to give you the 27. Okay, so 27 divided by sine 55 equals 32.96 feet. That's my first answer. Okay. So, Devin, I know you're good. Jerome, how are you? Tanis? Were there any questions at all on assignment? Now, I know you'll do a bit of catch up, but basically, does that seem pretty straightforward? Okay. So let's continue on, because it's nice to, well, let's try and get as much done as we can in class before they shut us down. So I am going to move on to lesson 4 because we did lesson 3 yesterday. And you know what, you guys, 99% of what I say is the same thing. Now, the beauty of the sine, cos, and tan, as I said yesterday, it's better than Pythagoras, to be honest, because Pythagoras only solves for a missing side. The sine, cos, and tan ratios, because there's more parts with them, right? There's two sides in Pythagoras, there's two sides in the sine, cos, and tan and an angle. This formula, if you remember, was just side squared plus side squared equals hypotenuse squared. So it just contains sides. It only gives you side lengths, but this side, because there's an angle in here, we can also use them to solve for missing angles, which is what we're going to do today. So, once again, there's nothing new to learn in the terms of the formulas. There's still sine, cos, and tan. And it says the ratios can also be used to find missing angle. We start the same way. So what did I say before? Label your triangle. Here's my angle, right? We're always going to have an angle. The angle is used to label the sides according to where they are in relation to the angle, right? So here's my angle. This time, though, I don't know the angle measure, right? That's what they're telling me to find. But it's still here, right? This is where it is. It's nestled in this corner. So according to the angle, what would be the labels on the two sides that you see?
Hypotenuse and opposite.
Yeah, which one's the hypotenuse? The 41. And then the opposite would be this one, right? This is the adjacent side, right? Once again, the A and the H create the angle, but I don't need the adjacent side. I recommend you not writing it in, because otherwise it gets confusing. This clearly tells me which ratio I need, and it is sine, okay? Now, I write it again, just record my formula, and now I'm substituting. This time, I know the sides of my triangle. I don't know theta. That's my unknown. So sine theta equals op over hypotenuse, okay? Now there's a problem here, a little bit of a problem, a little bit of a wrinkle. You're told to solve for theta, right? Now, right now this says sine of theta. Sine of theta is not the same as theta. I have to, this is, I mentioned yesterday, it's kind of like a Mr. Alexander or Mr. Brown. These two guys go together, but I really do want to know the identity of the angle by itself without the sine, but it is an important math. It's not really a math operator, but it's a math function. I have to get rid of that function. So before I do that, and I think you guys have had a bit of experience. When you look at any scientific calculator, if you look where sine, cos, and tan are, what do you see right above sine, cos, and tan? The sine minus 1, the cos minus 1, and the tan minus 1. That's kind of like the cancel sine, cancel cos, cancel tan buttons, right? So those are the ones I want. So that's what I'm going to use to cancel this sine out. But the calculator, these are the steps that I show with the calculator. If I want just theta, I got to cancel this guy out. So theta equals, I have to access that sine cancel button, right? And then I'm just going to do the division. 26 divided by 41. That's it. That's just a little extra step in there. So blue button and then the sign, and you should see the sign minus 1. Okay? And then it's just 26 divided by 41. And we get, now we still are, I know it's kind of odd, especially from what you've probably used to, we're still going to round our decimals to 2. I'll just check the answers quick. Okay, these answers aren't rounded, so I'll say 39 degrees. Theta equals 39 degrees. That's it. It's actually maybe a little easier even than solving for a side. I don't know. Because you know it's, notice you're always going to know your two sides. So you never have to make that decision. Oh, is it a multiply or a divide? It's always going to be a divide. And you just have to get rid of, do the cancel sign or cancel cos or cancel tan button. Okay. Let's try the next example. Let's label together, but then I'm going to get you to set it up. Okay, here's my angle. Even though we don't know its true identity, it's still the boss in that it decides how the sides are labeled. Okay, so I've got the 42.5 and the 19.7. What label will the 42.5 have on it? Yeah. And then the 19.7? Adjacent. Okay, that leads us to, Cliff, which trig ratio uses op and adjacent? It's right up on the board or on your paper.
It's 10.
10, right?
Yeah.
No dispute. So tan equals op over adjacent. Okay, so substitute everything in appropriately. See if you can come up with an answer.
The book you're working on is different than the one we have it.
Is it?
But just a few words.
Yeah.
Are the numbers the same?
The numbers are the same, but we don't have the formulas written on our timelines. It also, in the example, it doesn't actually say solve for theta, it just doesn't say anything like it's assumed, but
Can I see?
the books are all over the place. I noticed on this,
That's what I want to spend these next 2 weeks doing.
there,
I
right?
haven't taught this course for a while.
So on the, even on the assignment before this, it said the 100 to the 100, which would be the 3 decimals, and then.
No, 100 is 2.
Is 100?
Yeah, 1,000 is 3.
It's not 1 and 10.
10 is 1 is 1.
Oh, okay. I was gonna ask you about that, because I was confused that it said 100.
The books that we're getting tomorrow, I edited, I spent last week editing them, so they should be good.
Okay.
Yeah, there's nothing like debilitating about this book, just a few weird, like, yeah, especially when the decimals don't line up or something.
Okay, anyone want to share their answer?
65.18.
Yeah, that's what I got too. So tan of theta equals op over adjacent. Theta will be equal to, I show my kind of cancel tan or shift tan. Some people describe it as shift tan because you have to press that second button. And then I just do my division. And we get 65.13. Now, in the grade 12 course, this and again, this book has to be re-edited a bit. In the grade 12 course, it's always 2 decimals, even for angles, but this book I noticed just has no decimals rounded to the whole number, so this book would show in the answers 65. Okay? I have a question for you. Think back to the beginning of this, to very first lesson. If I know that this angle measure is 65 degrees, what would the third angle be in this triangle then? How big would it be?
Mental mass. 25 degrees.
How'd you get that?
The angle's always equal 180, and if you know 2 of them, you can
Yeah.
just add them minus 1.
Yeah.
and you're-
All the 3 angles will always equal 180, right? If you know this is 90, which it is, you got your 180, subtract 90, subtract the 65, and the leftover is your third angle, right? So it's really easy to find the third angle. Okay, solve for theta. Take this one from the top. Do the whole thing for me.
Checking this side is Jason, right? At the bottom. Yes.
Why do they have that -1 there? Is it just showing you that you're putting that one first?
This, the sign and sign are sort of 2 different things. Sign is kind of representing the sign of whatever you're looking for, but now I wanna get rid of that sign. Get rid of the sign and I have to use the sign on this one. They undo each other. Kind of like multiply, divide, undo each other.
Mhm.
The two undo each other.
Can I see what? What'd you get, Blanca? 52 degrees?
Well, 51.75.
Any agree? Okay. So this side was, this is the hypotenuse, right? This side would be, wouldn't it be op?
Oh, so I put that on. Never mind.
Yeah.
Yeah, wouldn't that?
No, it's not her, you're right. Our theta is in the opposite corner.
Oh my God.
That's why.
Yeah.
You're right, you're both right.
Okay, well, let me just change something then. Sorry.
The other ones are okay. with
Your
this
theta's
one.
here?
Yeah.
Okay.
and it is in the.
Yeah, so I'm gonna do it that way.
corner, yeah.
Okay, thank you. Okay, so here's the,
Where you gonna move?
yeah, so this is adjacent. So it's cos. Agreed?
Yeah.
So cos theta is equal to adjacent over hypotenuse, right? So theta is going to be equal to shift cos, because I want this gone, right, Cliff? So that's why I have to use the shift cos, 13
Yeah.
divided by 21. Shift cos, 13 divided 21, and sure enough, we get 51.75. So that would round to 52. And make sure that you put your degree symbol, because thetas are measured, our thetas are measured in degrees. Okay? So now you've got this next assignment, which is the same thing, right? But it gives you practicing on labeling. It'll get kind of maybe a little tedious, I guess. But label, find your angles. You know it's always going to be an angle measure. I'll give you a bit of time to work on that.